Now, it is rare that you're actually going to use, well, it's not super rare, but it can be that you don't want to use a random variable exactly as it is, that you want to do something to it. So maybe you're going to be adding to it just a constant or even another random variable. Maybe you'll be multiplying it by a constant. So we're going to take a look and see what each of these does to the expected value and standard deviation so we can come up with some quick rules and shortcuts for you. So first of all, let's add 10 points to our previous dice game, the one where it was 0, 5, or 50. All right. Recall that our expected value was 10, our variance was 325, and the standard deviation was 18.03. All right. So basically what I'm doing is I'm going to go ahead and add to the list. I have to put in my first list. Sorry about that. So we need 0, 5, 50. Luckily, it doesn't take too long. Then the probabilities, which was 0.5 for the first one, and then let's see, it was 1.26 or 1/3 for the second one, and then 1/6 for the last one. Notice you can enter fractions directly into there, and it will convert it for you. So if I go ahead and run the one var stats like I did before, you can see that I'm going to get the expected value of 10, the variance of 325, and standard deviation of 18.03. So you see that there. So now I'm going to go back into my stats list and add 10 points to each of the values. Instead of doing it in the original list, I'm going to go ahead and go over to list 3. So that's kind of like my new list 1. And so I'll have 10, 15, and 60. And recalculate my one var stats. Oops, calculate one var stats. And then I'm going to do list 3 this time because that has my new values in it, and comma, and then my probabilities are still in list 2. Hit enter, and you can see that my expected value is 20, which kind of makes sense because if I add 10 points to here, 10 plus 10 is 20. My variance, and it doesn't really show variance here, so you can't really see it, but my standard deviation is exactly the same. So my new expected value was just obtained by adding 10 points. My new variance and standard deviation are actually unaffected. So if we add or subtract a constant to the random variable, this only impacts the expected value. So when we have e of x plus or minus c, it's basically e of x plus or minus c. For variance, it's just going to be the same old variance. So now let's go ahead and take a look at tripling the points in our previous game. Remember, here are the values we had last time. So I'm going to go ahead and add a list. It'll be list 4, I believe. And so instead of, well, 0 will still be 0 points, right? Then 15 and 150. So let's go ahead and do the one var stats with list 4, second list name 4, and then comma. And then we're going to still have probabilities in list 2. That hasn't changed. And let's take a look at what we got. Well, okay, expected value was 3 times bigger. That makes sense based on what we just did. My standard deviation did change. It's actually 3 times bigger. So if we multiply or divide a random variable by a constant, this also multiplies the expected value and the standard deviation. Because variance is standard deviation squared, it actually multiplies the variance by the constant squared. So here are basically the 3 rules when you multiply a random variable by a constant. Now here's a different one. Let's say we're going to play the game twice. Does that mean, is that just like multiplying everything by 2? Or what's going on there? So first of all, to play the game twice, okay, you really want, when you're combining random variables, you really want to look and see what's happening both times, all right? So you have to be more careful. So go ahead and do the sample tree. Here's game 1, and here are my probabilities, a half, a third, and a sixth for 0, 5, or 50 points. Here's game 2. Again, same probabilities because I don't expect game 2 and game 1 to be dependent upon each other. And then I'm going to take, here's where it gets different, okay? You look at your total points. And you see I have some points that were not even showing up before. For example, if I got 0 points on the first game, but, well, on this one, they kind of look like the points I had before. But here, I could get 10 points, or I could get 55 points. And on bottom, I can get 100 points. So here are my total points, and here's my probabilities. And basically, I'm going to combine these into a probability model by saying, okay, how many of these had 0? Well, only one of these had 0 points, and that was 1/4, right? Which I got by 1/2 times 1/2. I had 2 outcomes where I got 5 points. So that's 2 out of 6, or 1/3. For 10 points, there was only one way to do that, to get 5 points on the first game and 5 points on the second game. That was 1/9 when I multiplied those probabilities. To get 50 points, there were 2 ways to do that. So 2 out of 12, or 1/6. To get 55 points, I had to get either 50 points on the first game and 5 on the second, or 5 on the first and 50 on the second. So there were 2 ways to do that, 2 out of 18, or 1/9. And finally, there was only one way to get 100 points, which was to score 50 points on both of those. So basically, I went ahead and I entered a table into my calculator with an L1 and L2. It's like that. So I put in all these values, and when I entered them as fractions, they automatically converted them to decimals for me. Then I ran one var stats, and let's go ahead, and you can see, so my variance does look like it's just 10. I mean, my expected value here, E sub x, does look like it's just 10 plus 10. My standard deviation, on the other hand, is not exactly the same, because before, I'm pretty sure it was 18. So when we can't add expected values in this case. Always be a little careful with that, though. And basically, what this is going to look like is a Pythagorean theorem of standard deviation. So basically, the rules for combining expected values and variances is when you have 2 occurrences, 2 different trials, or 2 different experiments. So here's your experiment 1 plus or minus your experiment 2. Expected values should behave well. You should just be able to add or subtract those. Variances should behave well, but we're always adding variances, by the way. We never subtract variances. And I'll go over that in a little bit, why we always add. The standard deviation, though, is the square root of that sum, and that's kind of like the Pythagorean theorem. So in our example, when we added it, 10 plus 10 is 20. So that worked like what we expected. Variance worked like what we expected. It was basically 750. Standard deviation, because we have to take the square root of the sum of these two, that was not the same as multiplying the original standard deviation by 2, or adding both standard deviations. All right, so now let's revisit, why do we always add variances? So say you mix a quart of roughly 32 ounces of lemonade and you pour a glass from the pitcher, which is roughly, the glass is going to be 12 ounces, okay? How much is left in the pitcher? Well, you have variability in the 32 ounces, and you have variability in pouring the glass. So if I were just looking at this and I didn't pour the glass, I would have that variability there. Once I pour the glass, because there's variability there, maybe I pour a lot, maybe I pour a little. So it's going to increase the differences in the measurements for the pitcher. Say you have a pile of grapefruit weighing from 16 to 24 ounces, and you have a pile of oranges weighing from 9 to 13. Okay, we could pick one as random. So the sum, the biggest the sum could be is 37 ounces. The smallest it could be is 25. That difference is 12, right? And then you could say, okay, the difference between high and low just among the grapefruit is 8 ounces. The difference between high and low just among the oranges is 4 ounces. Well, what if I go back and subtract this? So let's say I take the biggest difference, 24 minus 9, and 16 minus 3. See how that variation is increasing? 16 minus 13 is 3. All right. 24 minus 9 is roughly 15. 3 to 15, that's roughly a 12-ounce difference. Kind of the same as we got when we added them. So always add your variances. Don't subtract them when we are combining random variables, even if the random variables are being subtracted.